test number 10, spring test number 10, sections 1 through 9. The last thing we did was simplifying radicals. This is our study guide. Number 1 says uh, find the square root of 162. Remember, you have to work with perfect squares and find which one is a factor of 162. Your perfect squares are 2 times 2. You can do 1 times 1, but it doesn't change anything. 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, and you can keep going past that. Most of us are not really comfortable with using all of these numbers though, so you have to it's kind of a trial and error to see which one is actually a factor of 162. We know that 4 is not, because 4 goes into the number 16 4 times, but then there's a 2 left over, so it won't go into it evenly. When we put 9 into it, it only goes into it once. It's 72's left over. So 9 actually goes into the number 162. So let's see how that's going to work out. If we separate it, we have the square root of 9 times, again, it goes into the number 16 once, and there's 7 left over, so it says 9 going in 72 8 times. And you can see that we didn't use, based on the fact that that gives us the number 18, you can see that we did not use the largest one, but it'll just make an extra step for us. The square root of 9 is the number 3. Notice it's not the square root of 3, it's just the number 3. But we can separate the number square root of 18, which we'll do next, because it's not a perfect square, but it has a factor out of one of these perfect squares. You can multiply one of those numbers by something and get the number 18. Clearly, we can use the number 9 to do it. So when we separate that, we get the number 9, or the square root of 9, times the square root of 2. The thing you have to remember to bring down is your number 3. Make sure you don't forget that one. So you wind up with 3, and the square root of 9 is the number 3. That's not the number 33, though. They're next to each other, which means you're multiplying by them, times the square root of 2, and the square root of 3, 3 times 3 is 9 times the square root of 2. The 3 questions you have to ask yourself to determine if this is a simplified answer or not. Are there any perfect squares? Again, these are your perfect squares. Are there any perfect squares that you can multiply by and get the number that is inside of the radical symbol? Can we get that number if we multiply it by 4 or 9 or 16? No. The other 2 questions you have to ask yourself involve fractions. The first one, is there a radical at the bottom of a fraction? So does it say like 1 over the square root of 2? That's at the bottom of the fraction. No, there's no fraction at all here. And the third one deals with something that looks like number 2. Is there a fraction inside of the radical itself? No, there's no fractions at all for number 1, so therefore that one is a simplified answer. For number 2, what you want to do is you want to separate it first. You have the square root of 21 over the square root of 121. So separate it. Make it the square root of 21 over the square root of 121. So all we did was separated it. Then what we need to do is we need to go ahead and see if there's a perfect square that we can multiply by. Is there a factor of 21 that's a perfect square? You can check through your numbers: 4, 9, 16, 25. By the time you get to 25, it gets larger than 21, so you can't multiply any of those by it. And you can do the same thing with your 121. When you see the number 4 goes into the number 12, it does evenly, but there's a 1 left over. The number 9 goes into the number 12, and there's a 3 left over, it becomes 31. 16 doesn't go into it because 4 wasn't a factor. So this is actually one. We'll count number 21. It's actually not a really tough problem, but we haven't gotten to this one yet. I didn't realize this one snuck on the test. It went as far as to sneak on here this early. So we'll leave this one as a bonus, everybody. But what you need to do is you need to rationalize the denominator, which means you need to multiply by the square root of 121 over the square root of 121. I think we talked about this once. Anytime you multiplying straight across, anytime you multiply the same radical by itself, notice how this one is, that just gives you the number 121 outside of the radical. It gives you that number outside of it. Then when you multiply the square root of 121 times the square root of 21, you're going to get a great big number. But the rationalizing part is what you need to understand how to do. At least multiply the bottom over itself. and it'll get rid of that radical, but we won't go any further with number 2. So let's consider that one a bonus. Same thing with number 3. That one snuck on there as well, so we'll consider both of those bonuses. Number 4 is the square root of 160 over 2. We can do this one, in fact. You can simplify it first, which a lot of people probably choose to do. That says 160 divided by 2, but when you separate it, we'll give you the square root of 80. Square root of 80. Then what you're going to want to do is separate that into your perfect squares. Again, your perfect squares: 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, and so on and so forth. We'll use we'll use the number 4 because it goes into 80. There might be one that's larger. We'll see in a second. The square root of 4 times the square root of 20, because 4 times 20 is the number 80. The square root of 4 is the number 2 times the square root of 20, and clearly we can see when we look at the square root of 20, there's another number that you can multiply by and get 20. That's a perfect square. The square root of 4 times the square root of 5. Make sure you bring down your 2. So what you wind up with is 2 times 2. Notice the square root of 4 is not square root of 2. It's just 2 times the square root of 5. And when you multiply 2 times 2, you have 4 times the square root of 5. So that is your simplified answer. The rest of them will go a little bit more smoothly than number 2 and 3 showing up that early on it. Number 5 says solve the equation using square roots. Remember your order of operations. Always please excuse my dear Aunt Sally, or parentheses, exponents, multiplication and division, addition and subtraction. But when you're trying to undo stuff, you want to work backwards. So you look for any addition and subtraction first. Then you look for multiplication and division, finally, then followed by exponents, and finally parentheses. So as you're looking at 2 times x squared equals 242, there's no addition or subtraction, but the second step is multiplication and division. You can see it's multiplying by 2, so undo that by dividing by 2. You do it to that side, do it to the other side as well. That'll cancel out and leave you with x squared equals 121. So there's no more multiplication as you read that. X squared equals 121, but they do have the next step, an exponent. Undo an exponent, undo squaring something by taking the square root of it. If you take the square root of the left, do likewise to the right hand side. And I actually made a mistake. I'm looking back now that we get to 121 here. This one would have been a whole lot easier. Number 2 would have been a whole lot easier if I had realized that the square root of 21 over the square root of 121, if I had realized 121 was 11 right away. And that's actually a simplified number. We'll still count that one as a bonus if you want to go back. So we have the square root of 121, or what times itself is the number 121. X equals 11. Remember that that's the principal square root. You can also say that the number negative 11 will work as well. Number 6, x squared plus 20 equals 4. Get rid of plus 20. Again, you want to do addition and subtraction first, so subtract 20. Do the same thing to the other side, and you have x squared equals negative 16. Watch what's going to happen with this one. Notice we came to a negative number. Undo. Now we don't have any more. We don't have any multiplication or division, but you do have something being squared. So undo that by taking the square root. Do the same thing on the other side. So what you have is x is the square root of a negative 16. Remember that negative 16 can't be under the radical like that. Anytime it is, x is undefined. There's no answer. You could also write it as this, on null set, undefined. Gets a little bit easier at this point. Things we were more familiar with from a few weeks ago. 9 squared means 9 times itself, which is 81. Negative 14 squared is negative 14 times negative 14. Notice they're both in parentheses. That's why it's not 14 times 14. Negative 14 times negative 14 is a positive 196. For 3/4 squared, you got to make sure both things get squared. 3 gets squared and 4 gets squared. 3 squared is the number 9, and 4 squared is the number 16. Check and make sure there's no number that goes into both of those, and it's considered simplified along with these. 10 says the square root of 50. Now this is going back to what we did, the last thing we did. working using your perfect squares. Remember, write your perfect square sum down when you get your test somewheres. That way you can know when you write it on your scratch paper. That way you can just use it back as a reference. Remember, 2 times 2, 3 times 3, 4 times 4. Those are your perfect squares. 5 times 5. And we won't go any further than that because we know we want to use the number 25. You can multiply the square root of 25 times the square root of 2. That gives you the square root of 50. It also helps us break it down. The square root of 25 means what times itself is 25? 5 is. Times the square root of 2 simplified. For number 11, separate it. The square root of 5 over the square root of 64. Square root of 5, there's no perfect square that goes into that. But the square root of 64 means what times itself is 64? 8 is. And then 4 over the square root of 10 means 4 over the square root of 10. What we need to do with that one, there's no perfect square that goes into it. You can look at your perfect squares. None of these multiply by anything to give you 10. But in order to undo this, you do what's called rationalizing. We mentioned it a little while ago. Whatever's at the bottom of the fraction, multiply it by that over itself. Remember, it doesn't matter what number you put over itself. Anytime you divide something by itself, it's equivalent to the number 1. So since we're multiplying this entire equation, or this entire expression, we should say, by 1, it's not going to change it. It's just going to change the form for us and allow it to be proper. 4 times the square root of 10 can be written just like that, 4 times the square root of 10. And anytime you have the same radical multiplying by itself, notice they're the same. All you do with those is take it from underneath the radical and say 10. Last thing you got to do with this one is the number 2 goes into both 4 and 10. 2 times 2 is 4, and 2 times 5 is 10. This is a simplified answer. 2 times the square root of 10 over 5. 13, 8 times 2 to the negative third. Remember, anytime something's rose to a negative power, you have to use its reciprocal, or you have to do what's called ride the elevator. Remember, everything's considered over 1. That doesn't tell you to move the decimal or anything like scientific notation. Don't let it confuse you with that. Since it's being raised to the negative exponent, it's got to go down. It was at the top, it's got to go down. So what you wind up with is 8 over the number 2 to the positive third power now. 8 over 2 to the positive third power means 2 times 2 times 2, which gives you 8 over the number 8. You can reread that as 8 divided by 8, which will simplify to 1. Same thing with number 14. You have 7 to the negative 2 power. It's got to ride the elevator down. It goes down. So what you have now is 11 to the 0 power over 7 now to the positive 2 power. Anything being raised to the 0 power, like 11, is the number 1. And 7 to the positive 2 power is 7 times 7, which is 49. All the same basis for number 15. All three of them are 8, 8, and 8. What you do when you're multiplying the same bases is you leave the base 8, but then you add the exponents. 1 plus a negative 6 means 1 minus 6. Plus a positive 5 means plus 5. So what you have is 8 to the 1 minus 6 is negative 5 plus 5 is 8 to the 0 power. And again, just like number 14, anything being raised to the 0 power, like 11 to the 0 power, is 1. 16, same basis. You have to understand that this one has a 1 that's not shown as a coefficient. It's not going to really come into play, though. We'll multiply 1 times 3, and we'll get the number 3 up front times h. And then since they're the same basis, you add the exponents. Negative 2 plus 9 is 3h. Negative 2 plus 9 is to the positive 7th. That's all you can do with that. 7 times 6, multiply the coefficients first. 7 times 6 is 42. Same bases are x. Notice they're the same. So x to the negative 8 plus 3. Add the exponents. Negative 8 plus 3. 42, x to the negative 5th power. This is not quite finished. Now we're raising something to the negative power. Remember, everything's over 1. That's being raised to a negative power, so it has to ride the elevator. Not 42, just x. 42 stays on the top. X to the negative 5th becomes x to the positive 5th. Multiply 5 times 7 times 5. 35 times 5 You get 35 times 5, and you get the number 5 times 7 times 5 is 175. But then notice you have two different bases. You have x to the 5th and x to the 4th. That's x to the 5 plus 4. And the other base you have is y to the 4th. So you don't add that one with the 5 plus 4. So we have 175. X to the 5 plus 4 is x to the 9th, y to the 4th. None of them have any negative exponents or anything. That's a simplified answer. Nineteen is raising a power to a power. Now we're not adding the exponents anymore. Now we're making sure the k is distributed that square. So that means k to the 8th times 2 this time. We're not adding them anymore. So k to the 8 times 2 is k to the 16th. That's all we can do with that. X is being raised to the 9th and also to the 0 power. That means x to the 9 times 0. Anything to the 0 is x to the 0 power. Do the same thing with the other x. X to the 7th squared means x to the 7 times 2. X to the 14th. So you have x to the 0 power, which is the number 1, times x to the 14th, which we can't do anything with that to simplify that x to the 14th. You have negative h to the 4th power being raised to the 5th power. So that's negative h being raised to the 4th power times 5. So that's negative h to the 20th power. And again, that's all we can do with that. 5n to the 5th to the 3rd, make sure everything gets the 3rd power. So 5 to the 3rd and n to the 5th to the 3rd, n to the 5 times 3. 5 to the 3rd is 5 times 5 is 25 times 5 is 125. And n to the 5 times 3 is n to the 15th. Then we have quotients, 3 squared over 3 to the 1st power. What you do with these, since now when we were multiplying them, we added the same exponents. I'm sorry, when we were multiplying the same bases, we added the exponents. Now we're dividing the same bases, you subtract the exponents. So 3 squared minus 1 becomes 3 to the 1st power, which simplifies to 3. Do the same thing with number 24. Y to the 10th over y to the 11th becomes y to the 10 minus 11, which is y to the negative 1 power. Again, it can't stay that way. It has to ride the elevator down. You're left with 1 on top over y to the 1st power, or 1 over y. Number 25, 11 squared over 11 to the 4th. 11 to the 2 minus 4 gives you 11 to the negative 2. Got to ride the elevator down. 1 over 11 squared, which is 1 over 121.